Okay. The capacitance of a parallel plate capacitor is 20 microfarad in air and 60 microfarad in the presence of a dielectric. What is the dielectric constant? So, first, you know that capacitance of a capacitor with respect to construction is what the dielectric constant times the area of the plate divided by the distance of the parallel plate. So now, but this one here, we now have two capacitors with the same area, the same distance apart. The only difference is that the dielectric is the medium between the parallel plates. Sometimes they put uh, liquid. Sometimes they put a paper, a kind of paper there. Sometimes they put other kind of element. Sometimes it's a vacuum or air. So whatever the type of dielectric it is, will also determine the capacitance of the capacitor. So now they ask, what is the dielectric constant? Now, if I will say for the first capacitor C1, I'll write epsilon times area over the distance. I'll say this epsilon 1 because the dielectric is different. Then for C2, I'll say is epsilon 2 times A over the area over D, over D. So now, if we are to find the dielectric constant, now you can see since the areas are the same and the distance apart are the same, they can cancel each other, because if you operate both of them, they will still cancel each other. So you are left C1 equals to that. So we have that C1 equals to what? E1, and then here C2 equals to what? E2. Now, since from this first equation here, you can get that from here you can get that C1 over epsilon will be equals to what? 1. And from here too, you can get that C2 over epsilon 2, this was epsilon 1, will still give you what? 1. So since this one equals to 1 and this one equals to 1, if you equate both of them, you have a C1 over epsilon 1 equals to what? C2 over epsilon 2. So we have C1 and we have C2. And then we don't know epsilon 2 and epsilon 1. How do we know epsilon 1 and epsilon 2? Epsilon 1 represents the relative dielectric of air, the relative dielectric constant of air, while epsilon 2 represents the relative dielectric constant of the new material medium. Then you have to recall that dielectric constant for any material medium is given as relative dielectric constant times dielectric constant of air or vacuum. You understand? So that relative dielectric constant can be given as what? Dielectric constant of the medium divided by dielectric constant of air. You understand? Dielectric constant of air. So now if you the relative dielectric constant of air is 1. So that will be 1 equals to that over epsilon naught. So the dielectric of air will be given as, okay, the relative dielectric of air is given as 1. Then for that of the new material medium is what we don't know. So here we will write this C1 will be, C1 will be 20 microfarad relative dielectric constant of air is 1. And then C2 is what? C2 is 60 microfarad. And the relative dielectric constant is what we don't know, E2. So if you make E2 the subject of the formula there by cross multiplying, E2 will be 60 divided by 20. Of course, microfarad there and another microfarad there. So microfarad will cancel microfarad, 20 will cancel 60 3 times. So the relative dielectric constant of the new material medium is 3. So if you want to know more about dielectric constants, there is a video on that. You can check the description. So subscribe to the channel, and then for online classes, you join my WhatsApp group and book a session. Thank you.